All right, good afternoon. We are doing this video for our PES and Electron Configuration Lab that we will be doing in class on Monday. This video is primarily for my remote students since you won't be in class. I do have a way for you to complete this activity at home. For everybody else, all my traditional students who might be watching this will just be extra explanation for completing this lab when we get in class on Monday. So where you want to start, I'm starting here in Schoology, and this is going to be a day 4 assignment in Unit 1. So you'll have a bell ringer in this folder, which will be set up a little bit different. I'm doing away with the Google Docs. It's just an assessment. You'll go in, answer the question in Schoology. And then also today we'll be talking about this long free response practice question, parts C and D. And then we will be doing the PES Electron Configuration Lab. So I'm going to go ahead and open that up, show you what it looks like. So there are the directions. What we're going to do is we're going to examine photoelectron spectra, PES, for the first 20 elements. So we have our directions are right here, and your student data sheet will be right here. You'll click on it. It should give you access. If it doesn't, please contact me so I can make sure and fix that. But it should give you access. It also should make you make a copy of it. So it's a Google document, so you'll be able to type on that. And that's where you'll put your answers, and that's what you will submit. So here are your directions. So you're going to have, if you're in class, you're going to have a set of PES data cards for the first 20 elements. And you're basically just going to go through and examine those and look at differences, and you're going to be labeling them. If you scroll down, you're going to be labeling them in that format where you will tell me which peak refers to is for the valence electron or the outermost electron, which peak is for the electron closest to the nucleus. So you'll have your nucleus here, and then you will draw the orbitals in and tell me which of these peaks corresponds to which orbital, and then you will also write on there the electron configuration. And you'll do the first 20 elements, and then you're going to be looking at similarities and differences, kind of looking for those periodic trends in those first 20 elements. Okay, so read through those directions and it'll give you, now it'll say in your directions, it says to arrange them by atomic number among your group, discuss what you notice from the peaks, and from one element to another, make a claim as to the reason for your observations and back up your claim with evidence. And then you will also arrange them according to groups as on the periodic table, paying close attention to the peaks for nitrogen and oxygen and the 3p peaks for phosphorus and sulfur. It's going to ask you what you noticed. You're going to make a claim and give some reasoning and evidence to back up your claim. Now, for my remote students, you will not have to arrange these because you don't have them at home. What I did for y'all is I put the PDF right here, and so you will open it with Cami, and this is what it'll look like. Now you can't arrange these, you can't move them around or anything, but you can think about them as far as their atomic number, and as far as having like a periodic table with you, so you could kind of envision where these would be on the periodic table if you can't actually lay them out, and then examine them from that perspective and look at similarities and differences in that way. You should notice some things about how they're arranged on the paper here, and that's going to help you. I'm not going to point that out. I'm going to let you try and figure that out, but that should help you to answer those two questions. So you don't have to print this off. You don't have to physically arrange it as they would be arranged on the periodic table. It's just going to be more of a mental exercise. That part of it will be more of a mental exercise for y'all. Okay, so let's go back here. All right, so for example, so what you'll do, for example, is you will have let's pick nitrogen. Okay, so this is the photoelectron spectrum for nitrogen, and what you want to do is look at the energy values. The lowest energy value means those electrons are going to be the easiest ones to pull off. Compared to the higher energy values, that means those are going to be the ones closest to the nucleus. So these electrons are going to be the ones closest to the nucleus, whereas these electrons will be the ones furthest away. So if this is our nucleus right here, and nitrogen has an atomic number of, and you're going to want to have a periodic table handy. There are all kinds of good periodic table apps if you don't have a paper copy. So nitrogen has an atomic number of 7, which means it has 7 electrons. Okay, so and it's in the second row of the periodic table. So that means we're in the second energy level. So this would be 2p, and there's 3 electrons in that p orbital. And then this is 2s2 and 1s2. The height of that peak indicates how many electrons are in that orbital. So you can see that this peak is just a little bit higher than this one. So it has 1 more electron than this one. So what you'll draw on here is you will draw the curved line indicating the energy level or the orbital. So here's one here for our 2p. This is our second energy level. And here's one here for our 1s. So it has 2 main energy levels. The S and the P are both, for that second one, the S and P are both on the same energy level. So we're not going to draw a third line because we're drawing I believe it said we're drawing the main energy level. Let me go back and check that direction. Working from the nucleus, I'll draw a curved energy line representing the orbitals at each peak. Okay, so at each peak on the PES diagram. So let's go back and fix that because that's not what we did. Okay, so then I am going to draw another curved line. Whoops. Let's go ahead and erase that. I'm going to draw another curved line here at this peak, and that's going to represent my 2s2. Okay, let's go back and look at our directions, make sure we got everything. And then we have to write our electron configuration in the corner of, and put how many protons we have in the nucleus. So this is going to be, this is going to be 7 protons. And our electron configuration is going to be 1s2, 2s2, 2p3. Okay. Okay, and then, like I said, when you get all those drawn, you're going to go back and you're going to examine similarities and differences and look for those periodic trends for remembering how they're arranged on the periodic table, and make a claim, provide some evidence, and give some reasoning to back up your evidence. So your evidence is going to be what supports your claim. Your claim is your question that you're asking. What trend do I see? What trend do I see in ionization energies? What trends do you see in the size of the atom? What trends do you see in the electron affinity? Those types of things. So you're looking at what things do you notice with that, and then make a claim. It appears that the atomic size is getting larger as you go down the periodic table. That might be a claim. You need some evidence to back that up. So you're going to have to look at this data that you just did, and you're going to look at that data and find what in that data supports that claim, and then why it supports that claim. Okay. you're going to put that evidence and claims and reasoning. We're going to do that in a Padlet. Since we're not all together, we're going to use a website called Padlet, and I will put the link in here. That is one thing I forgot. I'll put the link in here. And so here's an example. Here's a Padlet. It's an empty one right now. I'm going to share that with y'all. And what y'all will do is click the little pink button, and you will type something in. Here's your claim, and then you will type something about atomic size gets bigger, and then you will give me evidence, and then you will give me reasoning. And when you're done writing on it, you will it will stay here on the Padlet, and everybody will wind up seeing it. Let me see if I can find a. No, I don't want to do that. Okay, so there it is. Once you get done typing on it, you just click, touch the screen, and I believe you can move it around. Or if not, they will move around when somebody adds to it. So this way we can all see everybody's claims, evidence, and reasoning. And you can make comments. So I would like for you to make a comment on at least one person's claim, evidence, and reasoning, and be positive with your comment. You can do constructive criticism and be positive at the same time. Or if you don't find any constructive criticism, just make some type of comment on their scientific comment on their Padlet. Okay. So this link will be on Schoology, and you will go in and you will add to that. Okay. I think that's pretty much it for this. After you have made, now there are, I'm sorry, that's not actually true. When you go to the student data sheet, there are some questions that you will answer. That's not the student data sheet. That is the student data sheet. So you will read through part number 1 there, and you will answer questions 1 through 10. And then you will do part 2. That's where you will be drawing and annotating the PES diagrams. And then in part 3, you will answer those questions for part 3, 1 through, was it like 6? Okay. So this is the document that you will put all your answers on. Okay. And then this is the one you'll also submit to Schoology. Okay. So once you get all those questions answered, once you've annotated your cards, then you will submit this document to Schoology. Now, if you are remote, we're just going to have to kind of play around with it and see how this works, because I really want to see 2 things from my remote students. I want to see this student document here, and I want to see your annotated cards, because I need to see those to make sure you understand how to do the PES. So try submitting both of them. You can submit the Padlet, the cards. You ought to be able to submit by clicking, there should be a button that says turn in, but apparently there is not. Okay. Well, if you don't see a button that says turn in, we will need to download those and email them to me. Okay. So if you can't turn in both documents at the same time, I would like you to email your annotated cards. So email this PDF to me. And then the student data sheet you can submit through Schoology. Let's do it that way. Okay. So submit the student data sheet through Schoology and email the PDF, the annotated cards, the PES cards for the elements 1 through 20. Email that document to me, and then submit the other one through Schoology. Okay, that's just for my remote students. My traditional students, your cards will be in class, and you won't have to do that. I'll come around and look at yours, and you won't have to email them. Okay. All right. Then I think that is it for this lab. And hopefully doing this little introduction video will make things run a little smoother. And we'll have a few less questions. But as far as confusion, not as far as I don't want questions. I want questions. Just don't want it to be so confusing as the last one. So if you run across questions or you're still having questions about what to do, what's expected, please email me, message me, let me know, and we will answer those as best we can. Pay attention to the due dates that are put in Schoology so that you know when this needs to be turned in. I believe I'm going to make it due on Friday. So you will have the rest of the week to work on it, but you will also have other stuff to work on too. So you don't want to just let it pile up. And this seems to be fairly easy. Okay. So you'll have the Padlet, you'll have the annotated cards to do and you'll have the student data sheet to do for this lab. Okay. All right. And the link to the Padlet will be in Schoology. I'm going to put that in right after this video. Okay. Hope you have a great weekend.